Hello and welcome to this episode of Balancing a Chemical Equation. Today, we will be balancing potassium phosphate and aluminum nitrate yields potassium nitrate and aluminum phosphate. Woohoo, sounds fun. Let's get into it. So the first thing we have to do is look at the individual parts of the equation and rewrite them as their abbreviated compound forms. So, and along with their charges. So, potassium has a +1 charge, and a phosphate ion has a -3 charge. It's important to balance them just because in science we want everything to be nice and zeroed out. And also, like, neither one of them will affect each other too much. So, what we have to do to make those charges balanced is make there be 3 potassium ions so that its charge is actually raised to a +3, and a +3 and a -3 will zero out, and that's exactly what we want. So as you can see here, the first part was the compound with the charges, and the second part was when it was balanced. And we would just do that for the rest of the parts of the problem. So aluminum nitrate. As you can see, aluminum has a +3 charge and the nitrate has a -1 charge. And obviously they're not balanced. So to balance them, we need 3 nitrate parts along with our aluminum to raise the charges. But since the nitrate already has a subscript 3 in it, we have to put a parentheses around it and then add another subscript 3 so that it doesn't look like there's 33 nitrogens in our compound. But that would raise the charge of the nitrate to -3, and that would balance out the charges. And again with the potassium nitrate, so potassium has a +1 charge and nitrate has a -1 charge, and these actually just balance out just fine, so we don't have to do any work, we just combine them together and it's balanced. And the same thing happens again with the aluminum phosphate. Aluminum has a +3 charge and the phosphate has a -3, and they balance out and we're all good, and yeah. So now that we've balanced out all our charges, the next step is to count the number of atoms of each individual element on each side of the equation and make sure that they are the same. So we need to do that because of the law of conservation of matter, which says that nothing can be gained or taken away from any chemical reaction or anything in the world, really. Everything has to have the same amount of everything. So to keep that rule going, we have to see if it's balanced, see if there's the same amount, and if there isn't, we have to fix that. So let's see. Oh, so as you can see, this one is not balanced. So how are we going to fix this? Well, we can see that for potassium ions, here we have 3, here we have 3, and here we only have 1. And that's pretty easily fixable, so let's try and fix that first. So what we're going to do is add a 3 in front of this KNO molecule part. And we're going to do that because with this one is 3 and this one is 1, if we add 3, that'll make the K equal 3, and so they'll be balanced. And they will affect these other atoms, but we'll see if that works out or if we have to do anything else. Yeah. So, adding that 3, we have K equals 3, and K equals 3 over here, so that works. P equals 1 and P equals 1 over here, that is also working. And O was 13 over here, and we do have 13 oxygen atoms over here as well. A works out, it's fine, and nitrogen works out, sorry, not A, aluminum. But yeah, so everything is balanced, and that would be our final equation. And yeah, so that's it. That's pretty much how you do it. Congratulations on balancing your equation. Now you have a new skill. Go out and use it. Bring help to the world. You know, all that cool stuff. Um, have a nice day.